let's try to solve another Leetcode problem 1053, previous permutation with one swap. So if we have solved the problem in Leetcode with the title next permutation, so this is exactly the opposite. So I mean the problem is similar, we just need to think about it a little bit, and then we might be possible to solve the problem. Yeah. So the idea is that we're going to use the greedy idea. Yeah, so let's just read the problem. We are giving an array of positive integers array, not necessarily distinct. We're going to return the lexicographically largest permutation that is smaller than array. So for example, this is a 3 to 1. And what's going to be the next one smaller than this array? Yeah. So it's going to be 3, 1 to 2, of course. So that can be made with exactly one swap. So we need to make one swap. So for this 2 and 1, we need to make a swap of 1 and 2. And this is going to be the next smaller permutation. Yeah. So now that swap exchange of the position of two numbers, array I and array j. So this is the definition of the swap. Yeah. So if it cannot be done, we're going to return the same array. So in the second example, 115, it has already been the smallest permutation. We cannot find the next smaller one. So we're going to return the same array. So for the third example, we find 1 and this 9. Yeah, definitely this 9. If we want to make a smaller permutation, we need to swap this 9 with other numbers. Can we swap 9 with 4? We cannot, because this is not the next smaller permutation. We need to exchange this 9 with 7. Yeah, because only 9 with 7 is going to be the next smaller permutation. Yeah. So if we read the first 3 examples, we might think about a way to solve the problem. So yeah, it's going to be similar to the next permutation, but it's going to be much easier because we just need to find the swap. Yeah. So the first way is that we have to find a number which we must swap it. Yeah. So for example, if this array is increasing, can we find a number which we want to swap and make a smaller permutation? We cannot. Yeah. So this is the second example. If it is already increasing, definitely we cannot swap it, and we're gonna return this array. Yeah, we don't need to do anything because it is already increasing. So the condition that we only need to swap is that the array is not in increasing order. So maybe the array is like this. Definitely we want to make a swap, or maybe the array is like this. Yeah. So the condition is that how can we find in which place we need to have a swap? Yeah. So let's just check the third example. So in the third example, this is 1 to 9, and then it goes to 4 until to 7. So this is 1, this is 9, this is 4. Let me make it better. So the 7 should be here. Yeah, it cannot be bigger than 9. So this is going to be 7. Yeah. If we want to make a swap, we need to find a number which we must swap it. Yeah. So how can we find it? So in the next permutation, we want to check it from the right to the left. And similarly for here, for the next smaller previous permutation, maybe we're gonna call it a smaller permutation. We need to check it from the right to the left. So this is 7 to 6. 6 is smaller than 7. Definitely we don't need to swap. Yeah, because after swap it's gonna be the next bigger. We need to find the next smaller. Yeah. And then 6 to 4, we don't need to swap because 4 is smaller. And then 4 to 9, because 9 is bigger than 4. Definitely, this means, according to the greedy idea, we need to have a swap. Yeah. But for this 9, do we need to swap this 9 with 4, or this 9 with 6? This is a 6. Yeah, this is a 6, or 9 with 7. Definitely, we want to swap 9 with 7 because that's gonna be the next smaller permutation. Yeah. So we're gonna check from the right to the left until we find a number, the previous number, which is bigger than the current number. Then we're gonna make then we're gonna mark it as our index. For example, this is gonna be index A, and then we're gonna find another index 7. At 7, it's gonna be index B. So we just need to swap with index A and index B, and after swap, we're gonna get the final result. Yeah. So we need to think about the greedy idea a little bit about it. Yeah. So the condition is that we found a number, oh, this 9, definitely we need to swap. But we need to find which number we need to swap. Definitely it is this 7. Or maybe there's another number, maybe this is 11. Can we swap 9 with 11? Yeah, let's start to think about it. We cannot. Yeah, because if we swap it, that's going to be bigger. We need to find the next smaller. Definitely we cannot swap is 11. We have to find a number, yeah, which is smaller than 9 and bigger than the previous number. Yeah, maybe 7 or maybe 8. Definitely 11 is not okay because it is the next bigger element. We need to find the next smaller element, so it has to be a 7. Yeah, so this is the greedy idea. So up to here, we find, oh, that we need to swap. But before that, maybe there are going to be so many other numbers, it doesn't matter. Yeah, because we want to find the next smaller. Yeah, maybe others, there are going to be a swap, but it is not the next smaller. We have to select it from the right to the left. So this is the greedy idea. Yeah. Now let's just try to solve the problem. Yeah, we're going to prepare the length of the array. So let's just check the first condition, is that we're going to check the array is normally always be in increasing order. If it is always in increasing order, we're going to return the final array, right? Yeah. But how can we find that? Yeah, this is easy. We're going to just check from the from the second index I to n. Yeah. So if array I, normally it should be bigger than the previous, yeah. But if it is smaller than the previous index, so this means we're gonna return, we're gonna make a flag, we're gonna set the flag to false. Yeah, we're gonna use our flag, because in programming the flag is always a better way to flag something. We're gonna set the flag to false. So from the beginning, the flag we're gonna set it to true. So this means we find a case that didn't meet the condition, we're going to set the flag to false. So finally, we need to check this flag. Yeah. So if this flag is true, this means it is always in increasing order. So this means we need to return the final array. Yeah. So let's just submit it to check if it meets for the second case. As you can see, it works for the second testing case. It is okay. Yeah. So this is the second testing case. It is 115. So this is okay. Yeah. Now we need to find the position where we need to swap. So currently we don't need to swap, but what if we need to have a swap? So we're going to prepare two indexes A and B. So we're going to set the index A at position 0, and then we're going to find it. And how can we find it? It is also easy. We're going to find it from the right to the left. Yeah, so for I in range n minus 1, 0, and minus 1. Yeah. So if array I, let's say minus 1, if I minus 1 is more than array I. So for example, 6 is smaller than 7, but this 9 is more than array I. This means the previous number is more than the current number. What are we going to do? Yeah, we're going to set it. Yeah, right. So we're going to set the index A to I minus 1, and we're going to break it. Yeah. Then we're going to find the next index we need to swap. So we're going to use index B. So we're going to set it as A plus 1. Because A plus 1 must meet the condition. But we need to find this 7 instead of this number 4. How can we find the 7? We just need another for loop. Yeah. So for I in range, let's say we're going to use A plus 1. Yeah. Or A plus 2, I think it is also okay. Let's just say that A plus 1 to n. And if array I, is more than array I minus 1, and array I is less than array A. Yeah. So this means we found this number 7. 7 is less than 9. 7 is more than 6. Definitely we're gonna use this one. Yeah. So the index B gonna equal to I. So finally we're gonna swap it. Yeah. So array A, array B, gonna equal to array B and array A. Yeah, I think that's all about it. Yeah, so first of all, we're gonna find this index A. It means we're gonna check it from the right to the left until we find a number. Until we find a previous number, this 9 is more than this number 4, and then we're gonna set the index as 9, and then we're gonna find another number. So we're gonna check it from this number 4. Yeah, we're gonna check it from this number 4 until if this number is more than the previous number. Yeah, so the first one didn't meet the condition, but the second one, the 6 is more than 4, 6 is less than 9, so we're gonna set it. And for the 7, we're gonna set it. But here we don't need to have a break because we're gonna continue to check, yeah, until we find it. Now let me just submit it. As you can see, it works. Yeah. So as we can see, there are gonna be 3 for loops, and each for loop gonna be O(n) time. So the final time complexity gonna be O(n). Now let me just submit it. Yeah, as you can see, it works and it's pretty fast. I think that's all about it. Thanks for watching. See you next time.